right, this is Madison College. This is a college located near a ton of manufacturing facilities in Wisconsin. And they do a lot of videos and feature a lot of the stuff that's going on there. And they have some very good budgets to work with to make allow for students. In fact, oftentimes they partner with local industry to get the equipment that you see to do these kind of things because local industry recognizes the ability to invest in students because these are highly sought skills. And you see right here, we've got this panel. Now there's a robot in the background, you're going to see it, but this is a PLC. This is called an HMI panel right here that he's about to touch. And this HMI stands for Human Machine Interface. It's a way for operators to select things for a piece of equipment to do easily, and it's because it's a nice visual aid. Over here we've got some PLC equipment. Up here we've got switches and buttons. And what this particular robot is going to do is custom build a piece of tile. And it's going to do it slowly. It seems kind of fast when you're watching, but educational robots for the safety of the students are slowed down quite a bit. So this robot is likely running somewhere close to a tenth of the speed that it could run. But he's going to select this crisscrossed tile mosaic and have this robot build it, and we're going to watch. So we're going to watch this build. So he's going to press this, as I said. We'll watch this happen, and I'm going to let the video roll here. So you can see it's got 3 different mosaics. They could easily add more, make custom and this robot's going over and it's selecting little individual tiles that go into this pattern here. And again, this is going to be a crisscross. And again, you see that this robot has what we call a gripper on it, and it's a suction cup gripper. So what's happening is when it goes to the correct feeder, and it's got various feeders of various colors there, it actually turns on a vacuum, picks up the part, brings it over, places it in the proper storage area or ultimately the design area, and turns off the vacuum and it goes there. So we're laying all these individual tiles in, and then it's going to do something else. So it's finished making the pattern. So the conveyor system controlled by the PLC, the robot said, I'm done, basically, to the PLC. The PLC said, all right, I'm going to move it down here, and we're going to add some adhesive because these tiles are still loose in that little handling thing there. And it's going to bring this adhesive over. And again, you see the suction cups that it's doing this by. And it's going to lay it down on top of that and cut the adhesive and then move it down and press the adhesive in place. Now, while every process doesn't necessarily make mosaic tiles, obviously, but a lot of the very same equipment you see in this video is what's used at manufacturers everywhere. And I know a good FANUC robot will run you $20,000 to $25,000 in the real world cost. PLCs are a few hundred to a few grand, depending on how much you get into it. But this entire station that you're seeing here that built the video cut off, but that entire station maybe 40, 50, 60 grand, which is a salary these days. And plus robots don't get benefits. They don't get days off. They don't take work breaks. So now they do tear up, and that's why we need people to repair. And of course, they've got to be programmed. They're intelligent devices once they're programmed, but somebody's got to provide that programming. So the repair, the programming is all covered by people we call mechatronics technicians. Some can be engineers, industrial electricians. All of those are involved in the repair, maintenance, and upkeep of these types of equipment that you saw in that video. And this is just such a fun video, I couldn't help but include it on project in 2018 at the same college. But again, the knowledge that goes into doing this also goes into any process out there. So manufacturing may vary. It may be making cell phones, video games, you may be making tires, you may be making toilet paper is one item. But all of these processes that you're seeing here are um, used in manufacturing. I'm going to let you hear these guys because they do talk pretty well about their projects. I'm going to back it up. just a hair and let you hear them. And again, you can see another vacuum arm right here just picking them up. Now, this particular conveyor, if you watch, is actually putting them in one spot where it can pick it up. But some robots have vision and they have the capability of seeing parts without having to have them in a constant place on the conveyor. But in this particular situation, this robot's not using vision. It is picking from the same pick point each time. And this photo eye he's talking about is right here. It's this device here, and you can actually see the little laser pointer pointing there, so it knows something's there. So the robot won't come over to pick something up unless this photo eye detects it's there, but it's always going to be generally in this spot because this little chute here is ensuring that. So what he was showing you there, and I kind of interrupt the video trying to, I've got two pause buttons very close to each other, and I keep wanting to press the wrong one. But they're dropping them in this vacuum chute here, and they're going to bag them up. And the little tokens he's talking about are just tokens with the college logo on it. So this is just something they use to show off their technology. But again, this could be in a factory where two parts have to be put in a bag and a third part added by a different piece. And I did want to talk about this indexing table here for a moment. The reason these indexing tables, I'm trying to get a good shot of it, are so important is we oftentimes have here we go, that's what I'm looking for. We oftentimes have collaborative pieces of equipment working in a close-knit area, just as we see here. And the reason a circle and an indexing table is so nice is this guy can work in this area and this one can work in this area. They're built around the circle, and this process can just repeat itself over and over and over. So that's why we have these indexing tables to allow for two different pieces of equipment to be working in an area. It's just like sitting at a table with four people. You're sitting around this table so that you can accomplish things, whether you're playing cards, playing a game, whatever the case may be. That's what these collaborative pieces of equipment are doing in this index table. And the control for this guy is all done through PLCs as far as the movement and when, and it's all interchanged. There's data being shared between PLCs and robots and other pieces of equipment throughout the process of what they're doing here. And we'll take it up from there. So think about all the things that you get when you buy stuff that has screws and parts inside of little bags. This is something that can be done without the need for an operator. Now, an operator may have to intervene if the equipment tears up, but they're not actually performing the work, and that does two things. It keeps an operator from having to do very mundane processes. I mean, it's cool to watch these robots and these other pieces of equipment bag up these two starbursts and the token because it's technology we hadn't seen. But one, it wouldn't be that exciting to watch an operator do that. And secondly, I wouldn't want to be the operator that did that day after day after day after day. Great thing again about these robots: no brakes and no need for medical coverage, the whole 9 yards. So, but there is a high need for people who can interact with these type of processes, repair them, and get them back to going when they do have problems, because they're made by humans. They're going to have issues and they're going to need repair. Mechanical parts are going to wear. So this is just one way we can incorporate robotics and PLCs into manufacturing, and that manufacturing, as I said, can be far and wide as far as scale. And speaking of scale, this is Fanic's commercial video, but wanted to let you see one of the larger robots that's out there. So not everything's small parts. These things are very capable of handling intense, large loads. And when you think about it, their arms are just like our arms. If I hold a um, 20 pound weight under my arm and carry it around, that's going to be pretty heavy to me. But if I'm holding it way out at a distance, I'm going to need a lot more strength to be able to handle that. And you can see this thing has about a 6.2 meter reach. That's about 20 foot. And you're going to see it pick up 1,350 kilograms. That's 2.2 times that is probably about 3,000 pounds if I'm doing the math anywhere near right here. So you can see these things are not um, necessarily made for small parts. They can be made for larger parts. This particular video is showing that robot read that barcode. It knows what it's picking up, and it's going to move it. And you see it has absolutely no trouble moving that around. So quite a payload for this particular robot to do. And there are safety, talked about safety there. I didn't talk about that in another video, but if there's not plexiglass there, there can be light curtains and things like that, that if you cross near the path of this light curtain, it shuts down and keeps you from being hurt by this robot. Some of them actually come with vision that, excuse me, can see you if you get in, and they actually make collaborative robots that work with humans. I'll try to pull a quick video up of that as well. So these are collaborative robots working in the automotive industry, obviously, and you see Fanuc a lot just because they are #1 in the world for robotics, and they work in and around humans. If that human got too close to that robot as it was moving that object, it would stop, it would pause, and or at the very least slow down is one of the things they can do. Because these robots are capable of such intense speeds, um, one of the things we were taught was think of them as a propeller. They can move very, very rapidly, but some things just can't be done with a robot alone. And what you're seeing here are these collaborative robots that are working in and around human beings. So quite a bit of things. I think that particular last video, in fact, I talked to a guy that worked in a plant that did this. It was picking up like car glass and maybe putting the glue around it. I may have not went back far enough. Let's see. Um, yeah, that's what this looks like. It's a quick shot, but you can kind of see it's applying the glue, and then something's going to pick it up, and a human may put that in the car, or it may handle it itself. So anyway, just tons of ways we use robotics in the real world, and they can weld as well. That's another application. They can paint. All of the things you see here. So it really doesn't matter what you're building. You can utilize automation in whatever form, and that automation is going to vary far and wide depending on where the company is technology-wise. Some of them are incorporating quite a bit. Others are just getting started, but they're definitely all eager to get involved with these just because of the benefits that robotics present to a company. One company we work with quite a bit manufactures aluminum or extrudes aluminum, and they actually have a cell with 6 or 8 robots, Fanics, in it, where they build bumpers for Honda Automotive, and no human hands actually ever touch that bumper. Everything that's done inside of that cell is handled by um, robots only. But there are people that have to repair those, so that's why this kind of knowledge and this kind of skill is so highly sought in the manufacturing world.